Hi all, and welcome back to the next part of the series. So in this part, we're going to finish off by using functions to create patterns and replace the polygons with some simple facade panels. So as a recap, in part 1, we referenced some geometry, we created some quick forms, we linked that to some external data, we looked at some information feedback, and we did some initial panel breakdowns. In part 2, we generated some simple polygon nodes, we generated polygon arrays, and we looked at some custom panel placements. So in part 3, we're going to start with facade patterns, we're going to utilize functions, we're going to create simple facade panels, and then we'll look at a summary. So in this series, we started from this, and we're going to end up with this. So let's get started. So welcome back. So in the last series, we left off with having created some diamonds and triangles. And in this part, we're going to look at those diamonds and triangles and try and gather them together to create a facade pattern. So looking at the diagonals. So if we look at a photograph of the Gherkin, you can see here we've got those distinctive darker spiraling bands associated with those lighter ones. So one being the red band you can see and the blue band. So this time we're going to try and create those. So if we look at the pattern of that in a 2D form, what we're actually going to look at doing is selecting polygons that are staggering in each row as we go around the building. So you can see here just the orange polygons. If, say, we take the diamonds, we'll be stepping up the building, but stepping across the polygons. So we're using some functions to actually step across the array of polygons as we go up the building. So I created a function for this, and it's fairly simple, but let's run through it. So first we start with function. And then we set the inputs that we want. So this time I said polygon, and I actually put 2 square brackets in, which actually indicates that we're actually going to feed in an array. And I called that my poly, or my polys. Then I want to set up an integer, so just a number, to actually determine which column I'm going to start on. I have an integer for the span, so how many panels I want to take into that array. And then what it steps each time. So then we open the function with the curly brackets. And I set up what I want for the output. So I'm going to want a polygon, and it's going to be called polyarray. So then we start a loop. So we first start the first loop. So we're starting as you remember from the last time, we're actually starting from, say, the row itself. So for this, so for integer I equals 0 up to the count of my polys, which is the actual rows themselves. So then straight away we want to dive into the actual columns of the polygon. So in here I actually said, well, my poly list. So now I want to set up the list I want to grab out of the columns themselves. So and for this I'm going to use the J loop. So for int J equals D column. So what I want to do is start from what I set up as the initial start column. So it may be 0, or we actually have the ability now to actually say, let's start from column 3 or 4. And then we want to go up to J is less than the column that we actually specified. And then we have D span. So if I decide that I want to grab, so in the polygon model we want to grab is we're going to have a span of say 2 or 4 polygons. So depending on how wide that strip is, we're actually trying to do. So it's column plus the span, and then we integrate that iterate that each time by j. So then the next line we actually look at is the actual index itself. So this is the most complex part of this loop, because we actually have a polygon count that actually can go around the Gherkin in a circle. It'll actually loop back onto 0 itself. So what happens is you might say have 24 polygons, and as you're looping around in a spiral, it'll actually get to the end of that list and it'll either stop and won't continue. But what we want it to do is actually loop around and continue to loop around. So when it gets to 24, we want to go back to 0 again. So the method for that is we actually I set up a polygon index. So I said int poly index equals j. And then what I want to do is actually use a thing called modulo, which is actually a mathematical representation of how we actually work out the remainder of the thing. So I've actually put a comment in here that actually says the percentage sign represents the modulo operation, which is the remainder after the division. So for example, if an array was 0 to 24 and we had a number larger than 24, we would get that result. So for example, if we had 26 and we had a count of 25, 26 would give the remainder of 1. So we'd be back to 1 again. So, and etc. 27, 28. So as you loop around, it'll actually keep going and keep going. So and then if it's less than the actual number itself, so I said here, for example, if it was 25, so 25 doesn't go into say 15. So if you're up to number 15, it'll just return 15. So until it gets to sort of the number itself, then it just returns the actual number. So this is very handy for looping around a series. So some more examples out there, so check out some Excel or some various math sites and you get a better explanation than I can give here. But so now we set up the polygon index of where we are. And what I want to do is actually just grab that. So polygon index is j, and then percentage polygon I, which is the actual row we're in, dot count. So that actually works out the count of the row itself. We actually work out the modulo of the number we are versus the number of polygons in that list. We just grab that polygon and we actually put it in our list. So we say polylist.add, and we say my polys I, and then poly index. So we just put the poly index we just worked out. And what that does is it drops that's in the list. Then it loops around and continues to do that until it runs out of J's. And then once we've created the first row, we add that to the polygon array by going polyarray.add and then polylist. So then it adds the list we just created back into the poly array. And as it goes back to I, then it resets the polylist to 0 again, or to nothing, and then it starts again. And it continues to do that. The other key is here, the D column equals D column plus step. What we want to do is basically step across from where we actually started. So it's not just stepping incrementally, it's stepping from where we actually started. So if we start at 5, we don't want to start at 0. So 5, so we get 5 plus our step. So as it goes up to the next row, it goes, okay, I started at 5, and if our step is 1, now we're going to start at 6, and so forth. And it just keeps going through. That's how we get our spiral. And then at the end, we just return our poly array. And of course, we close the function with curly brackets, and we're ready to go. So as a quick example, here's a polygon array of just some flat polygon array, so we can actually see what it does in a flat situation. So I applied the diamonds and the triangles that we've got on what we did in part 2, and just to show you quickly what happens when I actually drag it in. So I'll drag in a polygon, and I'll change it to by function. And if I click on the little box, I can just drop in that function we just had a look at, and you can see my inputs here are my polys. So the polygon is going to be our polygon array. So for this, I'll just select bottom triangle. And so it's going to be that bottom triangle along the way. So now we want to work out what column we're going to start with. So for this, I might just set it to 1. Our span, so how many polygons we want to gather into this list. So we might say 2. And then our steps, so how many times we move across as we go up the columns. And you see here, we've got 2 polygons in each row, and it steps across by 1 each time. And so if we change the column to 5, it'll move across. So you see it works quite well, and it spirals around as it goes up. So when it runs out, it sort of steps across to the beginning again. So if I change the span to say 4, you can see it actually gets much wider. We get 4, and then it spirals back around to the beginning again. You can see it works quite well. Similarly, if you change the step, obviously we step 2 polygons each time. Now if I change that back, and I'll just change this back to 1, then I can link up let's link up the other polygons as well. So I'll just copy this node and paste it above and disconnect that and connect it to the top triangle. You can see it's offset a little bit, so the actual polygons aren't quite in alignment, so we can actually offset that by 1. And then finally we can link up the diamond poly. Linking up the diamond poly is slightly different. If we type in diamond panel 1 as our target point, we actually have to target the polygon within that. So we go dot diamond poly. If you remember back to how we actually created that generated node type, it actually had a polygon within that generated node type. So what we're trying to do is target something within the diamond poly. So if we just change the numbers on those just to get that back to 0, so we just change the starting column to 2, you can actually see we're actually starting to get that distinctive sort of spiral sort of shape. You can imagine this wrapped around a circular building. So we come across to where we left off part 2. We've got our diamonds and triangles. So now what we need to do is, I'll just rearrange these a little bit for us, the same as what we just had in that example. And if we drag in a polygon node and change it to by function, I might call this spiral 1 top triangle, just to give a bit of a name for it. And we'll copy that, we'll paste it, and I'll rename this to be spiral 1 bottom triangle. And I better drop in that function we just had, so just paste that in there. Oops. Open up and paste it so you can see that, so they're the same function. I find sometimes pressing apply is a bit annoying, so sort of click on the graph window and then click back on the editor. And similar in here, I can paste the same function in there. So now I've got those two running. We can quickly link those up. So I'll just type in some numbers in here. So starting column for the top triangles can be 0. The span for this is going to be 4, and the step is going to be 1. Similarly for the bottom triangle, we're going to start at 0. We're going to do span 4 and step 1. And we can link top triangle obviously to top triangle, and bottom one to the bottom triangles. We're getting that spiral effect. So I'm just going to copy that node and paste it up here, and we can disconnect and I'll just rename this first to be spiral 1 diamond. So we actually know what that is. We'll just disconnect this one and we'll connect that to diamond panel. And as you see, it fails because it's actually looking for a polygon, not a custom node type. So similarly to the last exercise, all we need to do is just click on this and put dot diamond poly, targeting that polygon within that custom node. So now if I select all of those, and I'll just right click and say set a display set for it so we can just see those. You can see it's almost there, just our top triangles are offset by 1. We just need to bring those back, so we just go into that and just change its start column to be 1, and you can see we've got our perfect spiral as it wraps up the building. So that's perfect, exactly what we wanted to do. So now to create the next spiral, or the next stripe, we can easily just right click and say copy this and paste it. And I might just change this to spiral 2. Just change the names of these. Might just change the end, just get rid of that 1. I'll just arrange that a little bit. So now all we have to do is change the start column. So we started at 0, so now if we start at 4 for this, and the span for this, the next stripe is actually wider, so we'll make the stripe 8. And we'll just offset these by 4 each time, so that's 5, and this is still 8 because the span's 8. And the bottom one will be, instead of 0, it'll be 4, and again, span 8. So now you can see it's all a bit hard to see because they're the same color. But now you can see we've got our first and second stripes. So that's our first stripe and our second stripe. So it's working really well. So now we can go ahead, and for this exercise I showed you just the manual way to do it is actually right click and copy both of those nodes and paste them again and continue on renaming them. So I sort of sped it up a bit here and just made it so there's spiral 3, 4, it goes up to spiral 12. There's 12 individual sort of stripes on the building. So you see as I go through, it's just incrementing it over by 2 and by 4 and 8 each time, so that you get the stripe of 4 and the stripe of 8. But it took maybe about 10 minutes to finish, and you can see it actually building up around the building as we go. And so there it is in its finished form, and you can see each of the rows has its own spiral. So if you want to do something special with each one, you can do that with 12 different sets of nodes. Or what I actually did was I created a new function that actually repeated that a number of times. So I actually put another function in to say how many times it repeats. And I'll leave that inside the download file so you can have a look for yourself and see how I wrote that function. So the next step for this might be to actually create a custom facade panel. And there's a few ways of doing that. So let's jump over to a new file. And this one's just called triangle panel. It doesn't really matter what we call it. First of all, I'm just going to click over to computational design and to home, and I'll just click on point, and it just asks you to create a base point. So that's an easy way to start that. And for this, I'm just going to turn it into wireframe view so we can see it a bit easier, and I'll just drop a point somewhere out there. So we just start with a point. So for this, I'm actually going to draw it in the sort of XZ plane. So I'm going to start with X of 1000 and Y of 0 and Z of 0. Gives us our point. Just type in there, 0. You can see the point, it's a static point there. Right click and copy, and I'll paste that a couple of times below. Give our triangle. The X value for this, I'll make this 500, and the Z value for this, I'll make 1000. And similarly for this, I'll make this one 1500, and the Z value 1000. So that gives us our sort of 3 points for our triangle. And you can see those 3 points there. Drag in a polygon node. So I'll drag that in, and it's by vertices, and you just click in the box and you can actually just select all the points and it automatically selects them for you. Just hit enter. Now we've got our polygon. So this is our base polygon that we actually use to generate our node type, and this is the input value. All the nodes before this are sort of irrelevant. It's just the polygon one we need to start with. So as with everything, there's a number of ways of actually making a custom sort of facade panel. So I'll show you a couple of different ways here. One way is to actually drag in, say, a solid node and change it to sweep profile along path to actually create a frame for our facade panel. And if you click on the drop down, when it loads, you can actually see I can actually use a closed curve and different offsets. So if here I change the closed curve to be a rectangle, and then in here we can actually set the, say, Y dimension and the X dimension of that. So if we set the X dimension to sort of 50 and the Y dimension say 100. Then we have an offset to which way, whether it sits inside or outside of our polygon. So we set that to 25 and the Y offset to 0, and we connect that path to our polygon. You can see we get a facade panel or a frame. And that works quite well. What it doesn't take into account though is the direction of the polygons. So whether the polygons are actually facing their normals, whether they're facing inwards or outwards. And it actually makes a difference when you're actually looking at those offsets, whether you need a positive or negative offset. So in here you might have to say a negative and it'll actually set it outside. So we could do some work and actually make sure that our polygons are all facing the right direction. So a lot of the times if you're just doing a quick concept model, you don't want to have to go through and actually ensure all your polygons are facing the right direction, or if you've got a combination of different polygons you've created from different areas, whether they're facing the right way. So one way I found to actually generate facade panels reliably on sort of whichever way the polygon's facing is to actually use a thickened to solid sort of method. So for that, I'm going to start with a new polygon, and I'm going to just offset this polygon inside the original polygon. So if we start there, we can actually say we need our polygon to be an offset method of distance. If we link up the polygon and offset method to be by distance, and we have two different things. We have to offset distance, so we're going to set that. So I'm going to type in a variable for this. So I'm going to say frame width. Oops. I'm going to say frame width equals 50, and I'll actually set up a variable for us. So we actually have a variable we can input later on. And then it says offset point. So we need a point, so just drag in a point node. And for the point node, we could actually use the polygon itself. So we always want to base everything off the polygon. We can't use the points. So we just said centroid of set, and we linked in the polygon. Then we could actually type in polygon dot and vertices. Of the actual polygon, it actually creates a point right in the center. So that's the direction we want to offset. We can actually make that invisible, so because you don't need to see it, and we can link that up and you can see we get an offset polygon inside of our triangle. So that works quite well. So now we've got a polygon and a point, and we've actually offset that polygon. So now we've really got our areas we can set up. So we drag in some solid nodes, and it's just going to be a solid node with offset from closed curve. Just change one to say facade glass. And we can just type in glass thickness. So I'm going to call this, actually just call it glass thickness equals 20. So that's going to be a glass thickness. So I might just change this glass thickness divided by 2. And that will make sure that both of these values we change the same thing. I'll copy that and paste it in the bottom one. And so our glass will be centered on that polygon, and it'll be half the thickness above and below. And then we've got a variable we can change later on. So now we've got our glass thickness. Let's look at the frame itself. We link this one to the outside polygon, which is polygon 1. And the offset distance, let's call this, say, frame depth equals 100. And we'll do the same thing. We'll divide that by 2. And we'll copy that and place it in the offset below. So now we've got it centered around the polygon. You can see it there, but it's solid at the moment. So what we want to do is create another polygon, another solid basically, and do a Boolean function. So for solid 2, we're going to link that to polygon 2, so the inside polygon. And for this, I just want it to be thicker than the other solid we have. So I'm going to say frame depth times 2. So actually doubles the depth, and I'll do that for both the above and below offset. Drop in another solid, and we'll go a Boolean operation. And we'll link solid 0 to the first solid, and solid 1 to solid 2. And the operation, click on there, and it's going to be a difference. And I'm going to rename this one to be facade frame. So now if we just change to a shaded view, you can actually see illustration view, you can actually see there's our frame and our glass panel. And so this will work no matter which way, whether the polygon's facing inwards or outwards, because it's centered around the polygon. It may not be as efficient as doing it with a profile, but for initial concept, quick to get a model up and running. So the one thing, it doesn't actually look like a facade panel. So what we can actually do is, if you click on the drop down, you can actually access the family and part. So if you click on part, it'll drop down list, and I'm going to go to curtain wall and select frame, and you can see it changes to the material and the properties of that. And similarly, I'm going to do it for glass. I'm going to click on the part, click on cladding, curtain wall, and click on glazing, and you can see we get material definitions for that as well. So now we've got a transparent glass panel and a aluminium frame. That's perfect. So we're pretty much set up now. So now we can actually generate our node type. We've got our variables. So if we click on, I'm just going to click on save, and if we click on generate node type under model, and in the name, let's type in facade triangle type 1. So type 1. And from the node, let's go select from node, and we select the polygon 1, which is our input polygon. And you can see we've got our blue inputs and our green sort of outputs. And for that, we need to click on polygon 1 to be replicable, so we can actually repeat it a number of times. Our facade width, depth, and frame to actually be our variables. So I'm going to set those to optional and type in the actual values. This will set the preset values when we actually drop the polygon in, so we don't have to type those in. And I'm going to just click store in my GC environment. Now, once I hit OK, it'll take a couple of seconds, and then in the node palette, we'll actually see a generated node type appear. For our other type of panel, for the, say, the darker panel, the darker stripe, I'm going to just click on the part. I'm actually going to just change the glass type to spandrel. Actually give us a darker glass type in the preset. And obviously that can be changed in the families and parts. So in here, I'm just going to type in generate a new node type with facade triangle type 2. And do exactly the same thing. Select the polygon 1 as our, oops, I clicked on the wrong thing. Select polygon 1 as our input. And do the same thing, set it to replicable and change the optional values to 50, 120. And store in my GC environment and click OK. So now we've got type 1 and type 2, so we've got our sort of spandrel glass and our clear glass. Now we just need to create a diamond panel. So we can do a similar thing. So let's drop in some points and make a diamond shape. So let's start with 0.5. Let's just type in some values in here. So I'm just going to put 5,000, type in 0, Z radiation 0. So, and then just copy that and paste it 3 more times to get 4 points for our diamond. And the names of these aren't important because they're not actually used in the generated node type. So I'll just change the values here to say X 4.5, Z 1,000, and for this Z 2,000, that'll be the top center point. And for this, it'll be 5,500 and a Z value of 1,000. So you can see if I zoom out on that and zoom out in the file, you can see there's our 4 points. Then drop our polygon in, select all the nodes, and it instantly links it up for us. So now I've got a diamond polygon to start with. So what I can actually do is just copy all the nodes we just generated over here and paste them over there. And what I've been careful to do is not select the actual variables we started with, because otherwise it would create a new variable for those as well. But in here, we're just going to relink the polygons we started with to be polygon 3 as our base polygon. And you can see it starts to reform as we go across there. And we just need to change a couple of these as well from polygon to polygon 3. And there we have it. So we've got our, pretty simply, we've got our diamond panel straight away. So I'm just going to call this, so we can't have the same name, I'm going to call it facade diamond glass, and I might call this facade diamond frame, just to be a different name than the other one. And so in here, I might just change this glass back to clear glass, and I'll do a similar thing. I'll generate a node type for facade diamond type 1. And this one just moved around, so polygon 3. So we'll just change those values as well. And finally, we'll change the glass to be spandrel glass. And we'll generate a node type facade diamond type 2. If we flip back to our model itself, we actually see 5 nodes because one's our original, remember our diamond polygon we actually used to create our thing. So now we have a diamond polygon and we have 4 custom facade panel types. What I'm going to do is just drag each of those into the model itself. And if we zoom in, you can see we've got different types. And if you actually click on the drop down, you can actually see those variables that we actually preset. So I'm just going to drag the triangles up there and put the diamonds sort of next to where the diamonds are. Make it a bit easier to see. Look at our diamond stripe 1 and stripe 2. So diamond stripe 1 is actually the darker one, and diamond stripe 2 is actually going to be the clearer one. So it's sort of reversed how we actually created them. So type 1 needs to go to diamond stripe 2. So all we need to do is basically just click on polygon 3 and link it up to that diamond stripe 2. If you can just see it spiraling around each row, generated node types on each one. And it does take a couple of minutes to actually cycle through here. It could be due to the fact of my computer speed, and also I'm recording at the same time. But I've left it recording just so you can actually see it populating as it's going up. And that's the final row. So now you can see we've got a little bit hard to see, but if I link up the second polygon, you'll actually see it populating. You can actually see that it's a bit darker. So it's if we link up, so I just linked up type 2 to diamond stripe 1, and you can see it populating up that as well. So for the triangles, what I did is I actually selected both triangles and right-clicked and said Defer Update, which actually stops the polygon, stops those nodes generating. So then what I did is I actually linked, say, type 1 up to bottom triangle stripe 2 and top triangle stripe 2, because I can use the same generated node type for both of those. And then I can actually also link up, say, type 2 to bottom triangle stripe 1 and top triangle stripe 1. And then once I've actually linked those up, I can actually right click again on both of those nodes and turn off the defer update. I'll cut to the finished product because it took a few minutes to generate. And here we are, we've got the triangles and the diamonds, and we sort of overlaid with some of the polygons at the moment. So what I'll do is I'll just select those nodes and right click in the view, which takes a minute because there's now, as you can see down the bottom, there's 16,128 objects. And if I right click and just set that to a display set, we'll get a better representation without the polygons over the top. So if we zoom in, now we can see the darker stripe and the lighter stripe. And you can see we've got some really nice junctions between the panels as they're all offset inside the polygon itself. And you can see those spirals running around. If we zoom in at the top, you can see, and you can see it worked really well. So as the final step of this process, what I typically do is then just drag in an export node, because I want to export those generated node types. So I'll drag in an export. I'll just turn off the auto export for now. And for the nodes themselves, I'll link that up to the 4 generated node types. And it does take a little bit of time sometimes when you drag over a node. So you can see you drag over this node, and it actually takes a second to actually generate. So sometimes it's actually faster just to type in the name rather than to actually link up using the wires. So, and to do that, just got to remember that when you're selecting multiple nodes, they have to be within curly brackets, separated by commas. So for this example, I'm just showing you, just link up those 4 nodes. So with those linked up, we just need to provide an export name. So for this, you can hit dots to do a browse, but I'll just type in a path. And for this, I'm going to type in C, I'm going to put in a C:/temp/Gherkin-export.dgn and close the inverted commas. And then finally, I'll just use the browse and I'll just select a seed file for that. So I'm just going to use the design seed from the Nutrimetric delivered workspace. And if I hit export, it takes a bit of time to export. I think it took on my computer best part of an hour, I think, by the time I actually got it done. And so here it is as the final export. And if we sort of rotate around the model, you can actually see those spirals and with the diamonds and triangles actually working really well. So really good for a concept model to actually get out. Obviously we can do more detail in the model, but for this, it's working really well. And so this is just a standard Open Buildings file now. You can actually utilize by any of the Open Buildings team that you have that don't actually use generative components to actually generate elevations, sections, or plans. We've actually assigned along the way, we've actually used families and parts. So if you hover over the glass panels, you can see here, you can actually see it's actually curtain wall and it's got a material and it'll actually have specifications. So this is actually also aluminium and it's got a curtain wall frame. So it'll actually have the cut weights and section patterns and everything preset for you. So as one other step, in the generated node type, you could probably assign some catalog items to them as well, which would set not only the family and part, but also set what property type for scheduling for later on. So that really leverages the power of having generative components embedded within Open Buildings. So we've started from a 2D profile line and continued right through to something that could really be used for documentation. So we made to the end of our series. I hope you've enjoyed the process, and if you have any comments, please leave them below.